In this video, I would like to show you how to do exponential smoothing in SAS. However, before we do anything, we should take a look at the data and see visually if there's level, trend, and seasonality. So for this, I'm not going to use the data set that you're going to use for your term project, but I'm going to use a different data set. So you're going to use the weekly supply data set. For this demonstration, I'm going to use a monthly sales data set. However, the logic in both cases will be quite similar. So let me first show you what the monthly sales data contains. So it has time, period, okay, first month, second month, third month, etc. And then you have the sales revenue depicted as value. Okay, so how do I draw a graph of this? So I'm going to use proc sgplot, and then my data will be supply chain management 6224 monthly sales. Okay. I'm going to run. So what do I want to plot? I want to plot a series where the x-axis is period, the time axis. Y-axis will be the value of monthly sales. Okay. So after I write all of this, I click run. And pretty soon, there you go. So I see the time series has trend. I see time series has seasonality. But I also see a structural break. Okay. So since there's a structural break, either I need to remedy this somehow, or I can just focus on this part. That is, I can use the data after the structural break. Okay, and it seems like the structural break happened around 2009, 2010. So I still have some good amount of data, but I just want to look at this closer and see if I have a nice, clean data set. So what I want to do is now, I don't want to plot the entire time series. I just want to look at it from, let's say, 2009 onwards, or let's say 2005. Okay. So for that, I go back to the code and I insert a conditional statement. Okay. So I want to say that I want to look at this data. I want to plot this series where the year of the month is greater than 2005. Okay, so I'm going to see the time series after 2005. So I click run. Okay, so it says so I click on the run icon. It's running. So I click on the run icon. So I can see the structural break here. So it looks like I can start at 2009. Okay, 2006, 7, 8, they're problematic. So what I'm going to do is I'm just going to change this to 2008 and see if this gives us a clear, nice seasonal time series. Yes. So there's no structural break here. We're starting with a level, we have trend, and we have seasonality. So now let's start thinking about exponential smoothing. In SAS, the exponential smoothing is done by the procedure proc ESM, exponential smoothing, data, supply chain management, 6224, monthly sales, okay, and comma, I need to again use the same constraint here, okay, so I'm just looking at data after 2008, okay, so run. So I need to say what my time variable is. My time variable is period, so ID period says that. And what is my interval? My interval is month. So in your case, you're going to do this weekly. So you're going to say interval equals week. And then you're going to say forecast. What are we forecasting? We're forecasting value. Okay. So, at this point, I forgot something. Where do I want to see the forecasts? I want to see the forecasts in out 2. Okay. So out 4 tells SAS to write the forecasts to this file, and this can be any file name. I just said out2 for whatever reason. Okay, so I'm going to run this. Okay, I don't want to run this anymore, so I select this, right click and run. Okay, so let me look at this. So I have no warnings, errors, fine. Results, output data. So in my output data, what I see is the period, okay, month. This is the actual. This is the predicted. This is our forecast, our prediction. Then we have upper and lower bounds. This is our range forecast. This is our point forecast. And then you see the error. And then this is the standard deviation. Okay. So this is our forecast, exponential smoothing forecast. Now I have a total of 114 rows. Okay. So to go to the end of the file, I click on this icon. So I have everything, all the actuals up to June 2017. Okay. For July, August, etc., for the next 12 months, I have observed no demand. So I have no actual observed demand for these periods. Okay. So for those, SAS has generated a forecast. Okay. And so this is the forecast that SAS has generated. Now, the question here is, as you can see, the forecasts are all the same. Okay, why? Because I did not tell SAS which exponential smoothing to use. And by default, SAS uses the simple exponential smoothing. So the idea is SAS assumes that there is a level, okay, and it continues into the future. There is no trend and no seasonality. Okay, that's the assumption under simple exponential smoothing. So it just gives me a flat line forecast. Okay, so let me see how I can change that, how I can fix this. So I'm going to come to here and I'm going to specify an option. Okay, I'm sorry, this should be model. Which model to use? Okay, now I'm going to use Winter's model. Okay, Winter's is the person's name. Winter is the person's last name who invented triple exponential smoothing. Okay, so it's instead of triple exponential smoothing, SAS calls it Winter's method. Okay, so then I can rerun this, and then I can see if the forecasts are all still the same. So right click, and then, okay, so no errors or warnings, that's good. So let me, contents, okay. So again, name of the variable, value, period, time, actuals, predictions, etc. Let's go to the end of the file. Yes, so these are the actuals that I have. These are the most recent actuals. And then I have different forecasts for the next 12 periods. Okay. So what if I want to forecast beyond 12 periods? Okay. So for that, I can add an option called lead. Okay. So lead will be how many periods into the future. Let's say 20. Okay. Lead is 12 by default, but if I want to forecast more than 12 periods, I just say lead 20. Okay. Let's select this and run. Okay. So now the number of total rows has increased, and now I have more than 12 forecasts. Okay. So far I have used the entire data to generate forecasts. Okay. However, I want to use the last few or the last several observations that I have as a holdout sample or out of sample or test sample. Okay. For that, I need to say I need to add the let's say this option back equals, let's say 8, or let me say 5. Okay. You can choose different numbers here. I want you to experiment with these numbers. Okay. So what's going to happen is when SAS fits the model, it's not going to use the last 5 observations. Okay. And it's going to do the calibration using the first part of the data, and then it will generate forecasts for the last 5 observations as if we don't know them. Plus, it's going to go 15 more observations for a total of 20 forecasts. Okay, so we will have 20 forecasts from this procedure. 5 of them will be for the last 5 observations that we have, and 15 remaining forecasts will be for the future periods. Okay, so let me select this and then right click. Okay, so let me go to the last page. So here I have 15 forecasts for the future. There will be a forecast for this, a forecast for this, okay, and then these last 3 will be holdout sample. Okay, so now how do I actually see this? Okay, how do I actually see this? To see this, I need to enter another option where I say I want to see the plots. Okay, plot equals, I want to see 2 plots. There are many plots you can ask SAS to do. I want to see model model forecasts. Model forecasts. And I want to see forecasts only. Okay, so I want to see these two plots. So select the procedure, right click. All right. So this is my actual data. So the small circles are my actual observations. The line is my forecast, and the blue areas are the range forecasts. Okay, so this dotted line is all the way up to my last 5 observations, and as you can see, these 5 appear after the dashed line, meaning that they are not included in the fitting process. So I have observations for these plus forecasts, okay? And then I have continued forecasts for the future 15 periods, okay? So this is the model plus forecasts. And then I have this. This is forecasts only. For these 5 periods, I have forecasts plus actuals, okay? And then I have other future forecasts. Okay, so I have the forecasts. I have in sample calibration. I have out of sample tests, validation. I have future forecasts, but what are the quality measures telling me? To get the quality measures, what I need to do is I come here, I click enter. So I would like some tables printed. Okay. So which tables do I want? I want the estimates. Okay. Alpha, beta, gamma estimates. Okay. And then I want forecasts printed out. I want basic statistics, and I want the performance. Okay, so let's select this procedure, right click and run. Okay, so now so this is input data set, length of seasonal cycle 12, because we said we want monthly. We're forecasting 20 periods into the future, and 5 periods are holdout sample. Okay. First observation, last observation, number of observations read. Okay. So this is alpha, level weight, trend weight, beta, and this is gamma, which is seasonal weight. Okay, so we see that this is 0.2 something, and it's statistically significant. Seasonal weight is also statistically significant. That's fine. But when it comes to trend weight, it's almost 0, and it's not statistically significant. Why? Because there's not a lot of change in the trend. Okay, so the level of the data set changes somewhat. The seasonality changes somewhat. However, trend seems to be very stable, so you don't need to update trend or correct trend as much as the other two. Okay, so we have seen this model and forecasts, forecasts only. So now these are the forecasts. Okay, we have 20 forecasts for the first 5. Okay, we know the actuals here. Okay, but we don't know the forecasts for these 15 remaining forecasts. Okay, now so this is this first table, statistics of fit, is for the calibration sample. And the following table is for the holdout sample, okay, validation sample. Okay, so within the first part of data, for example, R square is almost 99%. Very, very good. Mean forecast error, mean percent error, okay, mean absolute deviation, mean absolute error, mean absolute percentage error, etc. So these are for the first part of our data where we fit our model. Down below here, see, so for the first model, we have used 97 data points. Okay. Our validation sample has 5. Okay. 5 observations, the last 5. Okay. R square, 98%. Okay. MAPE, this much. Mean absolute deviation, mean absolute error, etc. So now you need to compare these two. How well does the model fit in sample data versus how well the model fits out of sample data. Okay. And this is how you basically use exponential smoothing model using SAS. Okay. So if you have any questions, let me know.